Let's try an example of a torque problem. Here we have a one-piece cylinder that is shaped with a core section protruding from a larger drum. You have a rope that's wrapped around the drum of radius R1 and exerts a force T1 to the right. Another rope wrapped around the core of the drum has a radius of R2 and has a force exerted as T2 in a downward direction. We're ultimately looking for net torque. Now remember, torque is defined as a force multiplied by a lever arm. But in this case, there's a couple of them, so we need to add them up. There'd be a torque created by object 1 or force 1, and there'd be a torque created by object 2 or force 2. We do, however, need to pay attention to directions. So when we add these torques together, we'd find that the first torque caused by tension 1 would tend to rotate this object in a clockwise direction. Therefore, the first torque is going to be a negative torque. And again, that would be found by taking the force multiplied by its lever arm. The second torque, you'll notice, would attempt to make this thing rotate in a counterclockwise direction. That means it's going to be a positive torque. And again, we could find that by taking its force and multiplying by its lever arm of R2. Now let's just say, for example, that we put some values on this. Maybe T1 is equal to 5 newtons at a radius of 1 meter, and T2 is equal to 6 newtons at a radius of half a meter. Now, if we were to plug these things in, we could find our net torque as a numerical value as well, where we would take T1 times R1 and put a negative sign in front of that, and add T2 times R2 and put a positive sign in front of that, or basically negative 5 plus 3, giving you an overall net torque of negative 2 Newton meters. Again, we can see here our units, the SI units of torque being labeled on there, and our total torque of 2 being in a negative direction, meaning this object is going to rotate clockwise. Now let's look at a cross product example so you can see just a little bit in how do you perform this cross product with values or vectors. So let's say that you have two vectors. A is 2i hat plus 3j hat, and B is negative 1i hat plus 2j hat. And we want to cross these two vectors. So A cross B, we could write them out in, again, our unit vector notation and cross the two of them together, remembering that anytime you cross values that are in parallel directions, it basically cancels out to nothing. What that means is that when I bring these two together, kind of think of it as like foiling. When I bring these two together, they're going to cancel out to nothing. When I cross the 2i hat with the 2j hat, if you use your right-hand rules, you would find that a 2i hat crossed with a 2j hat would give you a positive 4 in the positive k hat direction. Now when you cross the 3j hat with a negative I hat, you'd find that you have your thumb pointing in the positive k hat direction. 3 multiplied by the 1 would give you a value of 3, but it would be in the positive k hat direction. And again, you want to use your right hand rules there, showing that if you have your fingers pointing in a positive y direction and curl them into the negative x direction, you would actually end up with your thumb pointing in the positive z direction. And of course, again, when you multiply or cross the j with the j, that cancels out to nothing. So that when you find your total, your result or answer would be 7k hat as the solution to this cross product problem. Now you can do this with right hand rules and treating this thing more like a FOIL problem where you just multiply those values together and use your right hand rule to decide on direction of like positive or negative k hat directions or whatever that direction might be. But there's one other way that you can set up these problems, and that's with matrices. And you may be turned off by the idea of a matrix right now, but let me show you this really quickly, and you'll be able to see how this actually turns out to be a way to solve these problems fairly easily. To set it up as a matrix, you start out with your matrix having I, J, and K all across the top of the matrix. Then you start plugging in your values. A is going to go first, so it's A cross B. So A is going into our matrix first, and A is 2 in the I hat, 3 in the J hat, and nothing in the K hat. Now we're going to put in vector B. It was -1 in the I hat, 2 in the J hat, and nothing in the K hat. Now there's different ways that you can solve a matrix, but one of the ways that I was taught was to simply rewrite a couple of the rows. So I'm just copying over what I had in the first 2 rows of my matrix because this is going to make it easy for me to see. When I solve this matrix, I'm going to start running diagonals, multiplying them together. My first diagonal would be this one, where I have an I hat times a 3 times a 0. So the very first thing on my list is just going to be a 0. I could write a 0 or I could just write nothing. The next thing on my list is going to be this diagonal, a J hat times a 0 times a -1. Again, just plain 0. And my next one is going to be a K hat times a 2 times a 2, or 4 K hat. So I've finished all of my diagonals that go down and to the right, but I also need to look at diagonals going the opposite direction. When I take all of these diagonals going down and to the right, that's one chunk of stuff. And when I take all of my diagonals going down and to the left, that's going to be another chunk of stuff. And I'm actually going to subtract these 2 values. Now let's look at the other diagonals, the ones going down and to the right, or down and to the left. Here I would have J hat times 2 times 0, so that's nothing. I hat times 0 times 2, so that's nothing. And then my last one is K hat times 3 times -1, so that gives me -3 in the K hat direction. Now, like I said, what you do when you're solving these matrices is you take the down and to the right stuff and you add it all up, and then you subtract all the down and to the left stuff when you add that all up. What that means is that we're left with 4 K hat minus a -3 K hat, or positive 7 K hat. The exact same answer to my cross product problem, and yet I'm able to get that without having to use the right hand rule in any way. If you'd like to practice more of these in class, let me know and I can show you a few more examples.